Let's build a simple circuit. Here we have a pictorial diagram of a simple circuit like you find in a regular flashlight. You have a battery for the source of electric power and current. We have a light bulb representing the light source. We have conductors and a switch. When the switch is closed, we say it's on and the electricity flows. When the switch is open, we say it's off and open, and the light bulb is off. The electricity or the current flows from the negative side to the positive side. The actual electric charges, electrons, flow from the negative to the positive, indicated by the arrows. The circuit we're going to build can be represented as a pictorial diagram like this, which shows an LED, a resistor, and a battery power source, and wires. The reason for the resistor is to limit the current through the LED. The electric current flowing through the LED is controlled by the resistor. The resistor's purpose is to control the flow of current. Resistors are one of the most common electrical components, and without them we would not be able to control the flow of current. The more resistance there is in a circuit, the less current tends to flow. Without the resistor, the LED would get very bright and burn out quickly. So it's an important part of our circuit. Over on the right, we have the schematic diagram of the same circuit. And here we have a symbol representing a voltage source, our power supply. We have the lines representing the wires. We have a LED symbol, light emitting diode, and we have a resistor. Now notice that both of these diagrams show the electric current, the arrows indicating the flow going from positive to negative. That's called conventional current, and that is commonly done. In fact, most of the time we pretend that the electricity flows from positive to negative. In reality, it really flows from negative to positive, but because we can't see the electrons in the wire, we really don't care most of the time. But there are some times when it does matter. The reason why we have things backwards like this is because over 200 years ago, Benjamin Franklin made a guess, and he guessed that electricity flowed from positive to negative of a battery. He named the two sides of a battery positive and negative, and he just decided that the electricity flows from the positive to the negative. He guessed wrong. He guessed had 50-50 chance, and he guessed wrong, but oh well. We're kind of stuck with this problem ever since, and so sometimes we talk about conventional current flow going from positive to negative. Other times we talk about electron flow going from negative to positive. So here you see the diagrams indicating the flow from positive to negative. Okay, no problem. Now we're going to go ahead and build our circuit. We're going to need a light emitting diode. It does not matter what color. You have a number of different colors probably available to you, so you can select whichever one you want. I'm going to choose a green one. And if you look inside your LED, you'll notice that it has some parts inside of it. There's a larger piece of metal inside the plastic case, and that is called the cathode. And it usually, if the leads have not been trimmed on it, the shorter lead is connected to the cathode. And then the other piece, which is a smaller piece of metal inside the case, plastic case, is called the anode. Normally the anode is connected to positive and the cathode is connected to negative. This is again the symbol for a light emitting diode. The positive side being the anode and the negative being the cathode. So if we want this thing to conduct electricity and produce light, we would connect the anode to positive and the cathode to negative. Then we're going to need a resistor to limit the current in our circuit. And we're going to use a 1000 ohm resistor. The colors on the resistor indicate the resistance of the resistor. Now, how does that work? Well, the first two stripes on the resistor indicate the first two digits of the number. In this case, it's 1000 or 1 kilo ohm. A kilo means 1,000. And by the way, ohm is the unit of resistance. So the more ohms something has, a resistor has, for example, the less current will tend to flow through it for a given voltage. Brown represents a 1 and black represents a 0. So here we have 1, 0. And then we have the color red on the third band, which is called the multiplier. And that red means 2 or 2 more zeros. Or if you want to do it by multiplication, you can consider that to represent 100, or 10 raised to the 2 power. 10 times 10 is 100. So that's another way of it. This is really a scientific number here. It's 1 0 times 10 to the raised to the 2 power, or 1 0 with 2 more zeros after it. Then the other thing we're going to need for our circuit is a power supply or source of some kind. We could use a battery for that. In the case of our kit, we have a little power supply like this that is very handy, so we'll use that, and we can run it off either. What's nice about it is it regulates the voltage so that we can use a number of different sources of energy to power it that connect into this connector here. Now let's go look at our actual parts. Here we have a breadboard that we're going to use to build our circuit on. We have to have some way to mount our parts, and this is called a breadboard. It used to be that they used to take a piece of wood and mount components on the wood. And breadboards were a piece of wood that people would cut bread on, so that's where the name came from. Sometimes people would actually use a breadboard to build electrical circuits. Today we still call these breadboards. Also, they're called protoboards, and they're a very handy way to build electronic circuits. We're also going to need our LED, our light emitting diode. We need our resistor. We have a 1000 ohm resistor, and we need our power supply to provide electricity to the circuit. And we will need some wires. So we've got a couple wires. Now, to understand how the protoboard works, I'm going to show you a very nice program called Fritzing. Fritzing is a program you can download free. It runs in Linux, it runs in Apple iOS, and in Windows. So there's versions for each of those. And I happen to be running Linux right now, and I'm running, it looks the same no matter what operating system you use. And what I'm going to do is I'm going to show you how we'll assemble our circuit using this program. This program is a kind of computer-aided design program for electronics. And it's a very nice little program you can get for free, again, at fritzing.com, Fritzing.com. And it's created by a university in Germany. And they give it away, so that's nice. First thing we're going to need is a breadboard. Over here on the right side of the program Fritzing, you can find the various different parts that it comes with, and you can, in fact, you can even add ones to it. I'm going to get out a breadboard here. I'm going to pull out a breadboard, just like the one we're going to use in our real circuit. Now, how does the breadboard work? The breadboard has little holes in it, and the purpose for the holes is so you can connect devices to the breadboard. For example, I could go over here on the right side and get a resistor. Let's pull out a resistor. Here's a resistor. And I could put the resistor into the holes and make a connection like that. I'm just going to set that aside for a moment. But what I want to do is show you how the holes work. There are some long strips of holes along the top. Underneath these holes are some metal clips that connect all the holes together. If I click on one of these holes, all the other holes that are connected to it by those metal clips turn yellow. So you see that there's one strip running along the top there next to the blue stripe that has all those holes connected together. And then right below it there's another strip that is next to the red stripe, and those are all connected together. So what those are used for power supply, for giving voltage to your circuit. And then we have we also have two more strips just like that on the other side of the protoboard, which are very useful as well to make connections. So they're actually the same. They're just connected up the same way. If you click on one of the holes with your mouse, you see that they turn yellow. So you have two separate ones there. Then you have these holes that are in groups of 5. If I click on one of these groups of 5, you see that the holes turn yellow. And so you notice that they're always in groups of 5 and they run vertically in this particular orientation. And in the middle of the protoboard there's a channel that runs down that separates a group of these on the top and on the bottom of the board, or right and left depending on how you have it oriented. So you see these strips down here are connected together, but they're not connected to the ones right on the other side of the channel. These are they're separate. So those are not connected to, whoops, accidentally threw my board away. Get it back here. Come back, board. There we go. Now, I want to make some connections here. Now, one thing I can do is use wires to make connections. Let's say I want to make a connection between the blue striped long series of holes on the top to the other one on the other side here. So what I can do is I can connect it with a wire. Now, what's nice about this program is you just click on a hole like this and it will pull a wire magically out of the hole. Now, of course, that doesn't really work with a real protoboard, but in this case it does. So I just pulled a wire out and I just connected up the long row on the top with the long row on the bottom that's next to the blue stripes. Now if I click on one of these holes, any one of them, they all turn yellow on both of them. Now that indicates that they're electrically connected. So it's easy sometimes to accidentally pull a wire out of the holes. I can even change the shape of the wire if I want to, just to make it look neater here. So I'm just going to connect my negative or blue striped holes together. That would usually be used for your negative supply. And I'm also going to pull out a wire and connect up the red ones. And I can make that look a little neater too. Something like that. And you can also change the colors of the wires. Maybe make this wire be, instead of blue, maybe make it be black. And this wire, let's make it be red. Okay, you can do that. Now, what else do we need here? I just did that just to show you how the wiring works. I could also hook a couple of these strips together. Let's say I wanted to hook up this set 5 strips to these 5 strips here. I could do that. I just pull out a wire from one of these strips and connect it to the other, to a hole on the other set of strips, like that. Now if I click on one of these holes, you see that they all turn yellow. So there's a wire, a jumper wire across there. Okay, let's build our circuit now. We're going to build our simple circuit. So let's see. First of all, we need, let's go ahead and get our light emitting diode. There's an LED. I'll put the light emitting diode in here. Now I'm going to poke it in 2 holes like that. There we go. By the way, I don't need this wire here anymore. I'll just go ahead and take it out. You just press the delete key on your keyboard and after you select it with your mouse, and it takes it away. And I want to put my resistor in the circuit. So what I'm going to do now is only one wire goes in each hole. So I'm going to move this resistor here and I'm going to connect one side of it to the hole. How do you know it connects to a hole? Well, when you put the end of the component in the hole, it will change color. Another thing I can do is I can connect a wire to the LED. For example, I could pull a wire out of one of these holes and go up here to the resistor, do it like that. Now, that would be okay to do that, and maybe that would be a little neater. In fact, a lot of times you bend the leads on your resistor to connect it up to the particular holes that you want to use there. So I'll maybe do it like that. Move it down a little bit. And also I need to connect the other end of my resistor. So I'll pull out another wire and connect it. I don't have to use a wire, by the way. You can also connect the resistor directly in the holes. But I'm just doing it to make it a little easier to see. And the wires out of a resistor would not be red, would they? They would be silver or gray colored. So I'm just going to change those to gray color just to make it look better. Okay, great. Okay, now I've got my resistor connected to the LED, and I need to connect the LED to the circuit, to the power source. So I'm going to take a wire, I'm going to take a black wire and connect it from the negative side of the LED, which is called the cathode, and go up to the negative strip, like that. And that's going to be my black wire, so I'm going to change the color on that to be black. Now notice that those two are not, if I click somewhere on the negative strip here, it lights up all the strips that are, all the holes that are connected together. So you see that the entire black strip now is connected to all the way over to the negative side of the LED. Okay, one more thing I need to do to make this circuit work. I need to connect the positive side of my circuit to the resistor here. Now I could run a little wire from the strip that's connected to the resistor over to the positive strip on the protoboard like that. I could also run it down here too, it wouldn't matter, because there's a red strip down there, or positive strip, it wouldn't matter. So that's one or the other. I'll make that be a red wire. Change the color of that wire to red. There we go. There is my circuit as I'm going to build it. Now, when I built this program is kind of very nice because it also creates a schematic diagram for you. This is the schematic diagram that it made for us while we're building the circuit. And I'm going to zoom out a little bit here so we can see this. Now, it didn't make all the connections on the schematic diagram. It just put some of the components on there. I'm going to rotate this part a little bit here so that it's positioned a little better. And here we have a wire. I'm going to make the wire be positioned like that. And we need a power source. A power source for our circuit is not shown here. The reason being is that actually on our breadboard we haven't installed a power source yet. So let's do that. We need to get a power source from our selection of parts here. What is our power source? Well, we could use a battery. Here's a battery right here. That could work. And so I'll just go ahead and do that. I'm going to rotate that around 180 degrees so that it's oriented right, like that. And I'm going to connect that up. Now this needs to connect to our breadboard. So I'm going to pull out a wire here that goes to the negative side of the batteries. That would tend to be a black wire, so let's make it be a black wire. And then I'll pull out a red wire to another wire going to the red or positive connection. I'm going to make that be a red wire. And just to make it look right. There. I think I got that lined up pretty well. Okay. So now I have my battery connected. Let's look at the schematic diagram and see if it did. Oh yes, look at that. It did put the battery in there, but I noticed that one of the connections isn't made correctly. Let's see why. Look at the breadboard. Probably this wire isn't really connected to anything. Let's look at the schematic again. Well, for some reason it's not connected. Let's connect it on the schematic. We can do it on either side of the circuit. So there. Another thing is I'm going to rotate my battery a little bit to the 90 degrees. So, looks pretty good. Now my battery says 3 volts, and I really want to have it not say that. So I'm going to label it as 5 volts. Like that. Okay, and the resistor here also. I want it to be it's going to be 1,000 ohms, so let's make the label be, I'll call it resistor 1 or R1, 1,000 ohms. Try that again. There. Things are labeled correctly. Okay. There's our diagram. And then there's what I'm going to build on my breadboard. So let's go back to the breadboard view and build it. All right. I'm going to take my LED here, connect it up to my breadboard. Looking inside the LED to tell which side's positive and negative. You probably can't see that on the camera, but I'll go ahead and put it on my Protoboard. So I'm making a note of that the shorter lead is the cathode or the negative lead of the resistor. And again, looking at my diagram, I did have the positive side of the battery connected to the anode, which is the smaller piece of metal inside the LED. So I do have that right on there. And so I want to make sure I do that on my LED. Put that in the right way so it's oriented the same. I'm going to go ahead and put the resistor on the positive side of the LED. Is that the way I have the diagram? Let's take a look here. Now I have it on the negative side. Well, it doesn't really matter. So we'll go ahead and put it on the negative side. It doesn't matter which side the resistor is put on the circuit. It can be on either the positive side or the negative side. It really does not matter. So punch it in there. Sometimes the new Protoboards are pretty stiff. And I need to connect up my power supply. Now, this little power supply is pretty nice because it provides the voltages for your breadboard, and it just plugs into the breadboard like this so that you can have power. And then you can run it off of a 9-volt battery. There's a 9-volt battery that comes in your kit, and you can connect that up to the breadboard like this, and that'll power it, and you can turn it on and it will power, and the little light comes on the power supply. But of course I haven't hooked up my circuit, so it doesn't do anything on the circuit yet. What that makes is, if you connect it up right, I have the positive and negatives connected to the blue and red stripe there. Make sure you pay close attention that on the little power supply it indicates positive and negative there. I don't know if you can see that, but it says positive and negative, so make sure it's in right. You can put it in backwards, and then it'll reverse the two wires. Now all we need to do is make our connections to the light. We have to go, the positive wire is going to go over to the resistor, which is right there, and the negative wire goes to the cathode. Okay, if we hook that up right, it should light up, and it does. So there's our circuit. It's working. The LED simple circuit is completed. And, well, that's about it. That's all it does. It doesn't blink or anything because there's no reason for it to blink. It just stays on as long as the power supply is running. By the way, you notice that I'm running this off a battery, which works great. The 9-volt battery works great, and the 9-volt battery clip comes with your kit. And so just any 9-volt battery will work fine with this. If you want to, you can also get one of these This is a little power supply. This is a 9-volt AC/DC adapter. Make sure that on the plug that the center is the positive and the outside is the negative. That's usually the way they are. These are used for power supplies for lots of different things. And so if you get one like that fits your power supply, you can use that to power it as well. So here I'm going to plug that in and go ahead and plug in my little power supply over to a power strip off to the side here. And I'm powering it now off AC. So, you don't have to use a battery that way. It just runs off AC. Well, that's about it for this project. I'm going to ask you to try a little experiment with this project, so keep it connected. And so thank you for giving this a try.